Hello everybody, in this video we're going to talk about the inverse trig ratios. So we've done a video already on sine, cosine, and tangent. I'll link that in the cards right now. So in this video we're going to talk about the inverse sine, the inverse cosine, and the inverse of tangent. So let's start looking at this right triangle. Hopefully you notice that this is a special right triangle. Because of our side lengths are 1 and root 3 and our hypotenuse is 2, hopefully we recognize that this is a 30, 60, 90 right triangle. So if we want to review that, I've done a video on 30, 60, 90s, and that's in the cards right now. So our question down here says, which angle has a cosine of 1/2? So for cosine, remember we want to do adjacent over hypotenuse, right? And so toa, a over h, okay? So cosine adjacent over hypotenuse. So we want to say, hey, the cosine of x is equal to 1/2. So x is what angle? Is it 60-degree angle or is it the 30-degree angle? So we think adjacent over hypotenuse. Well, if we look at 30, the adjacent side to 30 is root 3. So it's not 30. So for 60, the adjacent side is 1 and the hypotenuse is 2. So we're going to say the cosine of 60 is equal to 1/2. Okay, so now if we think about the inverse, so if the cosine of 60 is equal to 1/2, then is the inverse cosine of 1/2 equal to 60? Okay, so let's look. If we have our calculator, so for me I have the TI-84 Plus CE graphing calculator, and what I'm going to do is type in cosine of 60. So when I do that, it gives me 0.5. Okay, so now on your graphing calculator, if you're using the TI-84 Plus, right above cosine should be cosine COS with a -1. So it looks like this, cosine, and it has -1 right here. So that -1 stands for inverse cosine. So you see the button above, the blue letters above sine say sine to the -1, and then tangent says tan to the -1. So that's inverse sine, inverse cosine, and inverse tangent, which is what we're talking about in this video. So this says now we're going to do second cosine. So that gives us cosine to the -1st. And if the cosine of 60 is 0.5, then the inverse cosine of 0.5 should give me 60 degrees, okay? And so that is what inverse is. Inverse trig ratios are going to give us the angle measure, okay? When we just talked about sine, cosine, and tangent, that was just relating the side lengths of a triangle to one another, right? How big are they? What's the ratio of those side lengths? So for inverse, we can still use the side lengths, but we're going to use the inverse feature on our calculator to get us the angle measure. Okay, so let's look at what we mean right here. So we have this purple triangle, triangle ABC. It says let angle A be an acute angle. So we've got inverse sine here in black, inverse cosine in white, and inverse tangent in yellow. So let's talk about all of these and like what would we actually type in our calculator to find the angle measure. That's kind of what we're going to see today. So for sine, it says if sine of A, so all of these we're talking about angle A, if sine of A equals x, so x is our degree, right? X is our ratio, right? So sine of A, so whatever A is, that's our angle measure. So x is our opposite over hypotenuse. So the inverse sine, so sine to the -1, times the x, which is our ratio, opposite over hypotenuse, is going to be equal to the measure of our angle. Okay, so here is what we have for like what we would actually type in our calculator to get our angle measure. So we would type sine, so second sine, that's going to give us inverse sine. And we would do whatever number, whatever the length is of the opposite side, so that's BC in this example. So opposite, and then over hypotenuse, which is the side opposite the right angle. So just like we did in that previous example where we found cosine inverse cosine of 1/2, that's because 1 was the adjacent side to the angle and 2 was the hypotenuse. So for inverse cosine, we just saw an example of that. So we would type in cosine, so second cosine to get inverse cosine. And we would just do the length of the adjacent side. So here with angle A, our adjacent side here is side AC over our hypotenuse, which once again is AB. And that would give us the measure of angle A. And for tangent, we're still going to do opposite over adjacent, but now we would type in second tangent to get the inverse tangent. And we would do opposite, which is BC, over the adjacent, which is AC, and that would give us the measure of angle A. So we can use inverse sine, inverse cosine, inverse tangent any one of those trig ratios to find the angle A. It just depends on what information is given to us in our right triangle. Okay, so let's look at just a couple examples of how we use our calculator to find these angle measures. So if we're going to do one of each of sine, or sine, cosine, and tangent. So we're going to take our calculator, and right now I know that the sine of A is equal to 0.55. So in my calculator, I'm just going to do inverse sine of 0.55 to see what I get. So I do second sine, 0.55. I hit enter, and I'm going to round this to the nearest tenth, and we get, I'll write it down here, 33.4, and this is degrees. Okay, because whenever you're using inverse sine, your answer is going to be in degrees because you're trying to find an angle measure. Whenever you're just using sine or cosine or tangent, you're going to get a side length or a ratio of two side lengths, so it's not a degree. Okay. All right, now cosine of B is 0.87. So to find the angle measure, we're going to type in our calculator inverse cosine of 0.87. So we go second cosine, 0.87. We hit enter, and this gives me 29.5. 29.5, and once again, it's degrees. Okay, and the last one we're going to do tangent of C is equal to 3.29. So in my calculator, we're going to do inverse tangent, and we're going to type in 3.29. So second tangent to get inverse tangent, and we're going to do 3.29, and we hit enter, and this gives me 73.1 degrees. Okay, so that's how you use the inverse trig ratios. And remember, inverse trig ratios are going to give me the angle measure.